In the last video, we talked about ancient Greek mathematician Euclid and his famous book Elements. After that, we saw something about statements and then its parts, which are true and false statements, in which true statements had two types, the universal true statements and the proved one. So, in mathematics, these universal truths are axioms and postulates about which we'll discuss today, and the proved truths are theorems, and I'll add two more, which are corollaries and lemma, which we'll keep for the next video. So finally we'll look about this stuff, and I'm gonna begin with axioms. You might have wondered, do we really need to prove everything we say in mathematics? The fact is that every domain in mathematics is based on some statements which are assumed to be true and are not proved. These are self-evident statements or axioms. And also, as I saw you in the flowchart, axioms are the universal truth, which means they are the true statements, but in such a way that they don't need any proof. Or you can say currently we don't have any proof for that true statements, as they are obvious and also they are self-evident. There are a tons of axioms around us. If I said 1 plus 1 equals 2, then this is an axiom too, as how can you prove that 1 plus 1 equals 2? We don't have any proof for it. Or you can say they are the base of mathematics, they are the basics. Because if we want to prove anything, we need axioms. I repeat, to prove anything, we always need at least one axiom, about which I'll tell in the next episode. So out of these tons of axioms, our favorite Euclid gave us 7 axioms in his Elements, which you can read by pausing the video if you want. Literally I am saying that they are really simple. As Euclid's first axiom says, things equal to the same thing are equal to one another. Let's understand this with an example. Suppose I have a pen with price 10 rupees and a chocolate also with the price 10 rupees. So by this axiom, the price of this pen and chocolates are equal, which means if A is equal to X and also B is equal to X, then the A is equal to B. Now it's quite easy to understand, right? Now let's move on to the second axiom of Euclid, which simply says if equals are added to equals, the wholes are equals. Let's understand this with an example. Suppose I have a pen with price 15 rupees and also I have a chocolate with price 10 rupees. Now when I add them up, the price of both pen and chocolate at once will be 25 rupees. It simply says if A is equal to C and B is equal to D, now when I add them up, A plus B will be equal to C plus D. Now that's the second axiom of Euclid. Now let's move on to the third one. The third axiom of Euclid is almost same to the second one, as it simply says if equals are subtracted from equals, the remainders are equal. In the second axiom, we added the equals, but in the third axiom, we subtracted them. I mean, if A is equal to C and B is equal to D, then A minus B will be equal to C minus D by this axiom. Yeah, that's it. That's the third axiom of Euclid. Now let's move on to the fourth one. The fourth axiom of Euclid is also really simple, as it simply says whole is greater than a part. Now let's understand this with an example. Suppose I have two same circles A and B, and I have cutted a small part from the circle B. Now by this axiom, the circle A will always be greater than circle B just because we have cutted a small part from circle B and circle B has been smaller. Yeah, that's it. Now as we have completed axiom 4, now let's dive into axiom 5. It says things that coincide with one another are equal to one another. Now let's see what this says. On the screen we have two shapes. Now let's coincide them to check if they are equal. If they coincide, then they are equal. But if they don't, they are not equal by this axiom. I hope you understand all these axioms. Now as you have seen, all these axioms are really simple just because they are really basics of mathematics. Now that's all for today, and in the next episode we'll see about postulates. Now see you then.